Morning, everyone. So, as a developer, I know it's really difficult to wake up before lunchtime on a Saturday, so I can see that this talk really motivated you to get out of bed, so that's great. So I'm going to talk about core data, and it assumes a bit of basic knowledge of core data, so bear with me if none of this makes sense. For this talk, I'd like to think of core data as having two sides. On the one side, you're working with managed objects, managed contexts, and on the other side is your persistent store, the file that gets written to disk. And core data does a great job of transferring data between these two sides. By default, if you're using core data, more than likely you'll be using the standard store type, which is backed by an SQLite database. So even though it's an SQLite database, the standard store type does a lot more than just writing to this database, and we'll see that in a minute. So why would you want to write your own store type if the standard one is so great? You may have some special requirements. For example, at Dashlane, we like to encrypt users' data, and we want to control the encryption and still drive our UI with core data. You may want to interface with remote data and at the same time still use core data to drive your UI. You might want to control the file format of the store file. You might have a specific file format for your platform. If you have specialized knowledge of another database technology, you may want to plug that into core data. And if nothing else, looking at how custom store types work gives you kind of an idea of how the inner workings of core data work. So there are two types of custom stores that are very different, and you can subclass these to create your own store type. The first one is NSAtomic Store and NSincrementalStore. And these both inherit from NSPersistent Store. You can't subclass NSPersistent Store and create your own, so these are the only options you have. NSAtomic Store, the integration's fairly simple, and it's really designed to work with small data sets. NSincrementalStore is much more complex, and you can incrementally load and save data, so it can work with very large data sets. So let's have a quick look at NSAtomic Store. So on this side, on the left side, you have your application with the data that's loaded in your table view, etc. And when you're working with core data and let's say you modify a managed object and then you save it, you need to update the cache node, and we'll see that in a minute. And then if you're saving your store file, then you need to save all the cache nodes to your store file. This is generally how an atomic store works. So core data really uses the cache nodes in the middle as a data source for your managed objects. And no matter how many managed objects you have swimming around in your application, there's only one instance of your cache node representation. And when you implement an NSAtomic Store, your main job is really just to save and load the in-memory cache nodes from the store file. So if we have a quick look at some of the APIs you have to implement, you have something called load, something called save, and something called new cache node. And we can just simplify these just to make it easier to understand. So for load, the signature is fairly empty. So this is called when NSPersistent container loads the store. And by the way, this API was announced last year. It's really great for simplifying your core data stack, so if you're not using it, I recommend having a look. And what you should do in this method is simply read your store file and populate the cache nodes. And the cache nodes are just mutable dictionaries representing your records. Save it's just the other way around. Again, the signature is pretty empty. But this is called when the context is saved to the store, and you simply serialize and write your cache nodes to your store file. And this last method is called new node. And here you have a managed object. And this is going to be called when a context saves new records. And what you have to do when you implement this is transfer all the properties and relationships within your managed object and populate that in a new cache node and return that. So as we've seen, these are some of the methods. There's a few more that you'd normally implement. But as you can see, when you're working with your application and your data, on the left side, when you create new NSManaged object instances, when you update them, you're simply updating the in-memory cache node. And then when you save, you're simply updating your store file. So just to mention that this is really designed for small data sets. So as your data set grows, the performance of loading and saving is obviously going to go downhill. If we look at an example of, let's say, a table view, how does an atomic store work when you're driving a table view using an atomic store? When, for example, let's say you're scrolling the table view, each time you're hitting a fault, you're simply transferring the in-memory data for your record into a managed object. And this is done automatically with an NSAtomic Store. You don't have to do any integration. And this is fairly fast because it's all in memory. So NSAtomic Store, it's fairly simple to implement. You have to be aware that all your data is going to be loaded into memory, and that in-memory cache is driving your managed objects. And I think one of the only real benefits is the file format of the store is up to you. You can write that file how you want. So NSincrementalStore is a bit more complex, and we'll go directly into some of the methods. So we have something called execute and new values for object, and we'll see what they do. So if we take a look at execute first, so the first property that's in the signature is NSPersistent Store Request. Now you need to, this method will be called for various reasons, and we'll see that in a minute. For example, you need to switch against the request to see if it's a fetch request. If it is a fetch request, this is where you need to pull the rows in your database that relate to the fetch request and only fetch the IDs of your objects. And then you do a bit more work, and in the end you return a list, an array of NSManaged objects that are false. There's no data in them. They just have their IDs. This can also be a save request. And in that case, you need to go through all the inserts, updates, and deletes, and then apply them to your database. And there are a couple of other cases you need to handle, but these are the two main ones. And in documentation, Apple say that there may be future requests that you have to handle gracefully, throw an error or whatnot. So just a word about fetch requests. If you look at the API for NSFetch request, there are lots of buttons and levers and properties that are applied to pull the correct number of rows. So when you implement execute request, you need to take all those properties into consideration. So things like predicates, sorting, limits. And I think the advice is start simple and build up the complexity as you go. So what does this do? So we saw in the previous method, you're returning faults. You're returning empty NSManaged objects. So this method is called when a fault is fired. So when in your application, as soon as you access one of the properties of your managed object, you're going to enter this method. And here, you need to go back into your database, and now you need to pull the real data for your record. And this is the kind of data flow that's going on, and this method is this part of the flow. So you're not returning an NS-managed object. What you're returning is a node. And core data takes care of converting that node into the relevant managed object. So this can be expensive depending on how you implement this method, what database you're using, whatnot. But going from a node to managed object is fairly fast. So when you implement an NSincrementalStore, there's an opportunity here to tweak the performance by caching the nodes, and you can decide how you do that. You're trying to match the performance of your store to your application. So you may have specific data needs or performance needs, and this is where you do it. So if we compare how NSincrementalStore fires faults compared to NSAtomic Store, when you're scrolling your table view, you're hitting that new values for object method. So it's really here where you want to make sure you're as performant as you can be. So NSincrementalStore is more complex. Everything you get for free with the standard store type, you need to implement yourself. So you need to pass predicates, you need to deal with sorting, handle limits. But there is scope for performance tuning if you know what you're doing. So, quick summary. The default store type is really fantastic, super fast. It works really great for most people's needs. But if you can't get what you want from the default store type, you can try to build your custom store, and Core Data does a great job of opening up enough of the backend for you to integrate your own store type. And there's, as we've seen, plenty of possibilities. You can use any database technology you want. You can interface with remote data. But there's a high implementation cost. You get a lot of things for free with the standard store type, and you have to implement them yourselves if you want to go down the route of a custom store type. This wasn't announced this year in 2017. It was actually opened up in 2011. There's a session called What's New in Core Data on iOS. There's a fairly short segment of that session dedicated to describing NSincrementalStore. And in 2009, NSAtomic Store was announced. So these are fairly old APIs, but I have to say the documentation is quite flaky. And there have been quite good articles written about these APIs. I recommend going through them. The Incremental Store Programming Guide, I think if you start directly there, it's quite challenging to understand what's going on. So as you familiarize yourself with the APIs, then definitely use the programming guide. But these articles are really great. And that's it. Thank you very much.
Thank you.
Thank you. So, first question. Why do you use core data instead of a custom solution? Why didn't use a different database or build your own?
I mean, our application is fairly simple. It's table views, so it makes sense to use a native solution. We don't like shipping our app with 80 pods, so we try to do everything with native technology if we can.
But you could have chosen to just drop core data because the backend store is not really well suited for your solution, and completely replace it by maybe just SQLite or local plist, whatever.
Yeah, maybe, but I think that
less fun.
I think you end up building core data if you go down that route eventually. You start thinking of features that already exist in core data. It is a large framework, and there's a lot. It's very heavy for probably what we're doing, but yeah, I mean, it works fine with core data.
Yeah, there are some tools really useful in core data.
Right.
Like the way you can model with a graph and
Exactly.
see that. I also know a few people that are actually using that but not using core data. That's interesting. You haven't told us much about how you actually implemented your own custom backend store.
So at Dashlane, we store users' passwords and credit cards, and this data set isn't huge. There's not millions of records, so an NSAtomic Store works fine, and it's fine to load all the users' data in memory. So the main purpose is to encrypt the store file. So we use something like SQL Cipher as the backing database for our core data backend.
Okay. While I was looking at your slide, I was thinking maybe that could be fun to try to implement a dedicated store, a custom store for interacting as an interface to a REST API.
Yeah.
Can we do that?
This is one of the examples that they mentioned in the session.
But is it a realistic thing, or is it just for? Have you tried to map what could be done?
If you look on GitHub and search for some of these API calls, you're not going to find an awful lot of people doing this. And I think one of the reasons possibly is the complexity of the integration. And it's quite daunting. The APIs don't make a lot of sense when you first look at them. But once you start to become more familiar with them, potentially it could be something people do. But you really have to want to drive your UI with core data. Otherwise, it doesn't make an awful lot of sense, I think.
Yeah, sure.
Yeah, if you need to use like a huge caching mechanism more than just caching the request responses, maybe it can be.
Right.
But
we have some questions from the audience. Specific questions actually. What about how the updates to the data are propagated to the managed objects?
How are the updates?
To the data are propagated to the managed objects?
Through core data. I mean, we use managed objects on our front end of our app. So when a user edits his password, we don't think about our store type. We're just using the front end of core data. We're updating the managed object and asking the content to save. And some of the things I've described is what happens after you hit save on a context. That's when your implementation kicks in and you have to write to your store file, etc. But the beauty of the custom store is the front end of core data is, you just have to declare, you have to register you're going to use the store type. You set up the URL at the beginning, but after that, you just use core data as normal.
All right.
It seems that you really like using core data, right?
I don't have a problem with it.
I'm not judging. I actually do.
It does have, its issues with multi-threading and faults. What are these things that aren't there? You can get into lots of knots, and I think with NS persistent container that was announced last year, I think it simplifies a lot of things, especially around save notifications, which were always a bit messy to deal with yourself. Now you don't have to think about it. You get a view context up front, so you can use it a lot more immediately than before, where when you create a new project, you say core data, and you just get this enormous dump in your app delegate. That's all now hidden away.
Actually, I have a question for the audience. Has anybody moved to core data after the announcements and the improvements that been made last year? Well, somebody actually.
Yeah,
so 2-3 hands. 4.
Who's using core data?
Wow.
Yeah, that's still a lot.
Yes.
I mean, we're always making fun of core data, but I think it's a technology that actually works. And it reminds me that last year we had a talk explaining the new stuff in core data, making it more visible.
I mean, it's really not Swifty, and it's really heavy use of KVO and whatnot, but if it works, why not?
You're not supposed to say Swifty.
Sorry.
And other question from the audience, how do you deal with asynchronous data fetching?
Say that again.
How do you deal with asynchronous data fetching?
We don't, you pull up a context and you pull your data, and I don't think I understand the question.
On the implementation side, I think. The question is how do you, I mean, how do they manage to actually ask your custom store to store some new data, and then you need some time to do that? Let's say you need to do the actual request to the server, and then you need to notify core data that it's actually done.
You work with core data from the front end. You don't write directly to your store. You always you work through core data. So when you pull data from your server and you want to put it in core data, you go through your context, you instantiate manage objects, and then you save them. You never, I mean, you cannot write to the store and expect core data to magically understand you've added new data. And that's something that you need to be aware of.
All right.
Okay, I think we...
Basically all,
yeah, we can... Thank you a
Thanks.
lot for this
Thanks for listening.
very interesting talk and deep info data.